So right now, in that device that you are words with friendsing on, or Snapchatting, or tweeting on, or taking pictures of me with, you've got a large number of debugging features right in your hand. Some of them you've carried around in your pocket unknowingly for years. So I'm going to try to spend the next 45 minutes talking to you about the developer options section of the Android OS and how you can use it to tackle a variety of problems in your app. So my name is Andrea Falcone. I'm a software engineer at Google, where I work on Fabric. How many of you are familiar with Fabric or Crashlytics? We got some. So we were acquired by Google in January of this year. So we're over there working with the Firebase team. I've actually been working on Crashlytics for over 5 years. Just had my 5-year Crashiversary 2 days ago. So that was before any acquisition or before the development of Fabric. And I spent that time working on the original Crashlytics Android SDK, the beta by Crashlytics Android app, as well as all sorts of tooling around supporting Android developers, like working on our Android Studio plugin and our Gradle plugins. And I also extended the support for Android in our open source tool called Fastlane. It's an automation tool for automating your release. So in my core, I believe that in empowering developers to build better apps, both in the work that I do professionally, as well as giving talks at conferences on that topic. So as I mentioned, I've done a lot of Android stuff, but not a ton of Android app work, to be honest. The Beta by Crashlytics app is really the only example of an app I could point to that I've worked on, despite being here and speaking all the time. So compared to a lot of folks here at an Android developers conference, I actually have very little experience in that area because I work on tools. So I wrote this talk because I wanted to know more about debugging actual apps. And I thought that focusing on something that was available to everyone that had an Android device or emulator was a good way to narrow it down, a good place to start. So my goal is to show other developers how that a tool that you hold in your hand or have in your pocket all the time can actually help you solve problems without needing a USB cable or without needing to get whatever the latest tool is. So is there anyone who's not familiar with the developer options screen in the OS? Cool. Otherwise, I could tell you how to get there, but you are now a developer, so we can skip over that step. Great. So there are tons of options in here. It's really easy to get overwhelmed. Feel free to pull out your phones and follow along, as I'm going to try to cover 16 of the more interesting options. So it's going to be a little rapid fire, trying to give you a taste, put a little bug in your ear about something that you can go and really dive deep in on your app later on. Definitely poke around at the other 30 or so options that exist in the screen that I'm not going to have time to talk about. They do vary from OS to OS, so you might find something new in here from time to time, or be a little bit sad if you don't have access to some of the newer stuff that I'm talking about. Some things are new in N and O. So you've probably used at least one of these before, but my hope is that everyone will learn something new and go on and make development easier for you and make apps better for everyone else. So, have you ever gotten a bug report from a user? Show of hands. Have you heard of a bug in your app from a user? Okay. We have apps, we have bugs. Come on, people. Maybe someone's told you about some weird behavior, something that you can't reproduce and wasn't a crash. You weren't able to track it on any system like that. Well, the Take Bug Report developer option can help you with a problem like this. I like to call it the Give Me All the Info option as well. It's been available in the US for quite a while, but the interactive option is pretty new here. So when you pick this option, you get a pop-up choosing either interactive report or a full report. And what it's going to do is collect a crap load of information about what's happening on the device and email it to you. So it takes several minutes for this to work, to grab all the stuff that it needs. And it'll send off an email, open an email client for you to send off with a text file containing about 200,000 lines and 20 megs of really interesting stuff. And what's really great about the new interactive option is that there's a screenshot button. So a user can give you 6 screenshots of how they ran into a problem, as well as describe it with the details. And this gets all bundled up in a zip file that can be emailed off. So after you've asked the user to send you this bug report, you get this overwhelming bit of text here. So let's take a look at what's inside. There's a lot of outputs. Most of these are the results of running various Unix commands on the device. There's a ton of stuff, but let's look at some interesting things. So you can see the uptime. How long has this device been running? Get some stats about the internal storage card. Find things about a memory, how much total memory, free memory, cached, active memory. Maybe this problem is only happening in low memory situations. You can learn things about the processes and threads that are currently running. There's also app activities. This is a list of all of the activities on the device right now. Not just your app, all of the activities, as well as the active fragments, and their entire view hierarchy is laid out in this text file. So I told you it was huge, right? Like everything is in here. It can be a little bit hard to parse, but if you are good with your find or some command line find tools, you should be able to narrow it down and find the bits that you actually care about. And same for services and content providers running on the device. You're also able to see all of that kind of stuff. There's a system log, that's the logcat. Gives you the full output. When I tested this, I got about an hour of back logs. So that was good. You could see some events that led up to the problem, as well as the recent stack traces for any ANRs with the VM traces just now. So lots of goodies in there. Basically, a window or a look into what's happening on the system around the time that a bug occurs. Not necessarily a crash, just some behavior in your app that you can't otherwise explain. All right, have you ever needed to reproduce a bug that involved location? Well, if your app is really primarily location-based, you've definitely got more sophisticated tools than this one here. But this is great for a first-time debugging, diving into looking at GPS-aware components. It's also great for stealing swarm mayorships, if anybody's into that. You can set your location to a different place and go there and just keep checking in and get those crowns. You know, hot tip. So when I first tried this, it's called allow mock locations. And I was like, I'm going to turn this on, and it's going to work. Well, I was surprised that it was just a toggle. There was no prompt, nothing telling me where to put in my location. So it turns out in Android N, they changed the name of the option to be select mock location app, which is much more accurate to how this actually works. You click on it, and you get a list of apps that have this permission called access mock locations set in their manifest. And these are apps that are going to use a specific API to mock out location. You can download a variety of these apps from the Play Store, or you could make one yourself using the set test provider location API. So there are other ways to mock location. I told you I would show you how to do things only on device. I'll give you a little tip about running geo commands elsewhere. On an emulator, it's much more simple. You can use the location console in DDMS, or you can actually telnet to the emulator and use the geofix command. They don't work on actual devices, but if you're willing to use an emulator for this, this is definitely easier than taking a road trip with your physical device. So, cool. Who's ever had a bug in the onCreate method, or the startup of your app? All right, you got to keep launching Android Studio and debug to catch that, get it at the beginning. You can't just start the app up again because your breakpoints aren't going to get hit because they're at the beginning of your app. So you can use the wait for debugger option. It becomes available when you set a debug app. All right, similar in Android Studio, you can pick what app you're going to watch for debug in at the bottom of the Android monitor. Up the top, you've got the attached to running device. Similar, but this is going to get you before the app starts up. Once the app has started up, you've possibly gone past the bug that you're trying to capture. So if you turn this on, it's going to halt, wait for the debugger. That way your breakpoints that are set in those early parts are hit every time the app loads. So really, really easy to catch behavior in your onCreate, catch buggy behavior. You can also, if you want to change code on the device, code in the app, you can use the wait for debugger method. Same behavior. You'd set that before you want to, before the breakpoint that you're looking to get. So again, it's easier to do it with just the device that you have, but we'll give you some other options. Cool. So have you ever taken a video or screen capture or maybe received from a user, something that shows behavior, and maybe found it really hard to see what was happening. The show taps or show touches option basically gives you this little white circle that shows where the user is currently touching. So you can show it in the emulator, you can do it on a real device. All right, and it basically, let's look at a little video so we can see what it does. All right, so on the left, things are just going to start happening. You don't know where to look as a user. You can't figure out how the user activated search or what they were doing to scroll. But in the second video, there's just subtly this little white icon, a little white circle, showing you where the touch position is. So you get a better sense of what a user is doing. I also really like this for just making screen caps of an app to show people how it works. Maybe you can pitch it better this way. If you're going to put a demo up somewhere or tweet out a video, I like to turn this on. So maybe you've used show taps and you're looking for something with more information about specifically how the app perceives the user input. So in a similar vein, but with more technical details, is the pointer location. So let's look at this. All right, so things are going to just start happening here, and I'll walk through what you see in a minute. Sweet. So what did you see? Well, you saw crosshairs for the exact touch location. So you can see if the element that you expect to be touched on screen is actually in that location. You're like, I'm doing this, but it's not activating the element. It's because maybe you're not touching in the right place or the element's not the size that you think it is. As well as the mouse trail, so you can see the movement that the OS captured for the touches. And the color of this trail actually changes with the speed of the movement. So the red dots are the touch points, and the line that's drawn between them, that blue line, is like traced between them. So you can tell the speed by how far away the touch points are, and how the more red it is, the slower the user was going. The more blue you see, the faster they are, the fewer touch points that were captured in that span of time. And at the top, there's even more densely packed information. Starting from the left, you've got the number of touch points that are currently active and the number that have been captured since the last time you touched. That whole touch and move that I did there, that was like one capture. So it would show you how many were active. I took this screenshot while none were active because I needed my hands to take the screenshot. You also see the x, y coordinates when it's active, or the dx, dy, the delta, the change in the x and y direction from where you started touching to where you ended touching. The xv and the x, the v, the velocity in the x and the y direction, basically how fast were you moving, how quickly did you change locations. All right, and there's also information about pressure and size on there. Those can't be captured on devices that aren't capacitive touchscreens, so these are actually just estimated for most devices. So you can use this information to find bugs if you're in your sketching app. Does what you've drawn on screen not look like the input that the OS actually received? Or if you've got some custom gestures, why am I not seeing this thing that's supposed to be a flick up? Well, the user moved too slow, or that type of information. This is, let's go on back to pointer location. There it is, show pointer. Cool. All right. Let's move on. Sweet. All right. So have you ever need to know where one view stops and another one starts? Or maybe try to figure out why two things are laid out or spaced apart from each other on screen when you think they should be closer together? Show layout bounds can really help with that. So when you turn this on, screen kind of lights up like a Christmas tree. There's a lot of information here. But for each view, you're able to see the margins. That's the pink area around them. Some views don't have margins. The red lines are the optical bounds. The blue lines are the clip bounds. And the difference between optical and clip bounds are about things like shadow. Optical, you can see the bounds of where the element actually is. So, if two elements have a lot of space between them, where you're maybe not expecting it to be, you can say, well, is this margin inside of view A or view B? And that'll tell you what you need to adjust. Just looking at it without the bounds turned on, you're not necessarily able to get that information. Same thing, you're able to see the touch area for a particular view. You know, the area that activates the text fields, say the individual rows here is bigger than the text itself. But without this on, you don't necessarily see the area that you can touch to activate the view. Something that is new in O, starting with O, if you haven't defined any focus state colors, you're going to start getting some default colors for focus states in your app. So you can disable that by turning off the default focus highlight enabled, a long mumbly property. But you can also use show layout bounds to tell you which view actually has focus. So in the first one here, your text field has the focus. And if you look in the bottom one, the button, the OK button, had the focus at that time. And you could tell in that case, because there is ever so subtly a highlight color for that element. But for text, I guess you could see that the cursor was there. But there are plenty of cases where you may not have a visual distinction and you need to know what has focus. Turn this option on, and you're able to find out. Great. So confirming that your app is properly internationalized involves a lot of different components. But if you'd like to see if you've properly supported right-to-left layout languages, you can turn on force RTL layout direction. So this toggle basically just forces things to lay out from right to left instead of left to right, even if the language that you're using isn't typically right to left laid out. You could switch the device language to something that is laid out in that direction. However, I find it really difficult to navigate a device in a language that I can't read. So not only just my app, but the options. If I were to look at this screen in Persian or Arabic or Hebrew, I wouldn't know. There are no icons here. I can't tell the difference. I wouldn't know how to turn this option off. And so I could get myself stuck. So you can turn it on, and things start laying out on the right to left. Now, something that's interesting, when I was creating these slides, I found that there was at least one place in the developer options screen itself where the start and end padding hadn't been correctly used. They had used right and left padding, and the debugging label there, you see system, the system header is moved to the right, but the debugging header stayed on the left. So maybe that was left in here as a little Easter egg treat so I could find it, or maybe it's just a bug, I don't know. But same thing could happen in your own app. You might find that one element or sections of elements that aren't properly using the start and end padding, they're using right and left padding. So turn this on and make sure your whole app looks the way you expect it to, right to left laid out. All right. If you'd like to find drawing hotspots in your app, you can use Debug GPU overdraw. Another thing that you turn on and lots of colors start happening. Basically, this is going to tell you when the same place on screen has been drawn over multiple times by different views. All right, so you're going to see different colors. So when there's no background to an element, it's whatever color it's supposed to be, then it hasn't been drawn over at all. It's the element. The background is empty. 1x is typical. You have to draw something to see something, so that's what you'd expect to see. But as you start to get to green and pink and red, these are things that have been drawn over multiple times. You have multiple layers at work here. So something is drawing a background in that green section, but when you look at this settings screen, you don't necessarily see that they are anything but two white backgrounds. But your app has had to do more work to render that green part and the pink bits around those text fields and icons than it did for the bottom half. On one screen, maybe that isn't an issue, but think about your whole app, you could be doing a lot more work than you need to. So you can use other tools to actually tell you how to reduce the layers. Hierarchy viewer is a good one. You want to get more flat things. But in general, the lower the Z index is, you want those things to have transparent backgrounds. So you don't want to keep drawing backgrounds on top of backgrounds. You're not going to see them. You can check this using a lint check. So if you want to add this into your build, make sure that you don't have regressions in overdraw in your app. You could add a lint check to make that happen on, say, every commit or done in CI. So if you've got custom animations in your app and they don't look quite right, you might want to take a closer look. So you can scale the animations to see what they're doing. So the scale in here is a little bit tricky to understand. A 0.5 scale is half as fast, and a 10x scale is 10 times as fast. So bigger number, the faster it's, sorry, I just said that wrong, so you can see how tricky it is. A 0.5 scale is half the time, and a 10x scale is 10 times the time, so slower. I have a slide that will demonstrate this, so my words make more sense. So slow, let's look at normal animations. So these are window animations, so different apps coming in and out. This is normal on the left here. All right, that's how fast they typically come in. So let's look at them at 10x. This is going to be very, very slow. I have to talk slow in order for this video to complete. But you can see if you had something happening in here where it's moving differently than you expect, you're able to see when and why. And that at normal speed is maybe only a flicker, or maybe you don't see it at all, but it's not accurate. So you can also turn them off. Turn off window animations altogether. And so things are just happening over here. All right. If you turn off window animations, you can actually see if you've got any buggy behavior. When I was working at Twitter, I found a bug in the Periscope app where they had bound some app behavior, like navigating backwards in the, through the backstack to animation completion. And so the animation didn't happen because it was turned off on my device for whatever reason. And so it never completed, and so navigation never happened. So I would click back, or I was doing something I couldn't get out of a specific screen. I had no idea why. I kept writing bug reports and it's only you. Well, it was only me, but I had this option set to off. I didn't have any window animations, and so the app was broken under these conditions, which are, perfectly reasonable user conditions. So they fixed that. That was cool. So you may have noticed that there were a couple different options in the main screen. There was window animation scale and transition animation scale and animation duration. These are just different types of animation that happen in the app. So the first one we looked at was window, and that is different apps basically coming in and out. That's normal speed. It seems slow. You've also got transition animation. So this is between individual activities in your own app. All right. As you go back, that is the transition. That was really slow. All right. And there's also the animation duration. So this is smaller animations that happen inside the app. So if you watch the tabs while this one is running, the ripple. Watch how slow the ripple goes here. All right. So if you've got custom focus animations like this, and you've got something maybe wrong, or again, you're just trying to build out something cool and you can't see it at normal speed, slow them down, take a look at the individual frames. Cool. All right, so let's take our X-ray goggles and put them on for a minute and sort of look again at, just look inside our app and see what it's doing. Show surface updates is going to show you parts of your app that are doing work that isn't visible to the naked eye. So warning, the screen is going to do a bunch of flashing pink here for a minute. So show surface updates shows you parts of the screen that are doing work. And so in the first video, you're going to see that the whole screen lays out a little bit, and eventually it settles, and it doesn't flash pink anymore. I'm going to turn it on. It does a little bit, and then stops. It's done. This is not doing any more work. If you look at the second video, all right, this dialogue continues. It's animating. It's doing work. All right, and so that makes sense. That's going to keep going while it's animating. Video stopped. In the Beta by Crashlytics app, we had this option turned on and noticed that there was part of the screen that kept flashing pink, but nothing was obviously animating. In the app, we did have sort of like similar spinning loaders, but data had already filled in on the screen, and that loading indicator was gone. Well, it was not set to gone. It was actually still on the screen. It had just been set to invisible. So it was still there, still doing work. You just couldn't see it. So I've definitely benefited from just turning this on in my own apps and looking through them and making sure they're not doing work when they're not supposed to. All right. So if you're looking to debug hardware-backed views in your app, showing the hardware layer updates is pretty similar to the previous option, but it's green instead. No flashing in this one. So you can see which elements on screen here are rendered using the GPU. And if your app is behaving properly, you should only see, again, brief green highlights, not things that are constantly updating. All right. Have you ever had some jank in your app? I think we've all had a little jank in our lives. But if you don't know where to start looking to improve performance, you can look at the profile, or you can turn on the profile GPU rendering option, and this will give you a really good place to start. Quick visual. It's going to show you how long it takes to render certain parts, certain frames of your app. All right. You have a choice. You can show it on screen as bars, or in the ADB shell, but I said I was going to keep you in the device, so no USB cables for us. All right, I got another video for you. All right, so again, time here is laid out on the x-axis, and amount of work done is laid out on the y-axis. So as you scroll, as you start doing stuff, turn that on and off. All right, that's time going by. There's this magic green line down here at the bottom, and that represents the 16 millisecond target. Okay? Beyond that, frames that take longer than 16 milliseconds to render, you might have heard this before, that is outside of the 60 frames per second, sort of what we consider a rate that looks good, is not janky for users. All right? And so here, for whatever reason, there's a lot of jank. Things are well beyond that green line. All right. So every time it misses that, you've missed a frame, and your users could be seeing some stuttering images. Yeah. I'm so glad you asked. There's a lot of different. Obviously, there's a lot of different colors, indicating how the OS is handling the input and responding to it. There's a ton more information. You could do a whole talk about this, and I think some folks do. There may be one tomorrow on this topic. The bottom of this is cut off a little bit. But in the developer documentation, there's a whole section dedicated to using this option, reading the output, and then figuring out how to fix those kinds of problems. So my intention was to show you that it's here, let you turn it on for your app or other apps, and be like, oh, yep, I feel the jank, I see it, and then have some empathy to want to fix it, and have that benchmark of that green line to get down under. So what if you wanted to test accessibility in your app? Well, simulating color space is a neat way to test for the ability for people who are colorblind to differentiate colors or textures within your app. So it became available on Lollipop, I should note. So there are several types of color blindness that affect people, and it's when people can't see the difference between different shades or different colors. So yeah, these are some of the common types of color blindness. When you turn on simulate color space, which until you know what it means, that terminology probably isn't friendly. You don't look at it and say, I'm going to simulate color blindness with this option. But you're able to see that there are multiple different ways to transform your UI to test your UI for the ability to compare different elements. All right, so I took my own home screen and I turned on this option. One thing is that you can't capture the color output with ADB screen capture tool. So I had to actually take a device and take a picture of my phone. All the other things are using built-in screen capture tools, but at the layer at which these colors are applied is not transferred. So that's why they're a little bit weird. But so if you look at some of the icons, say the photos icon in not the far right, the one left of the far right, you can see that the red and green, what should be red and green here, are displayed as the same color. So that's, if those elements were next to each other, our user wouldn't necessarily be able to see the difference between them. So if you had, say, buttons laid out that were red and green, the boundary between them wouldn't be obvious. So there's also entire talks dedicated to accessibility and making your app more accessible. This is one quick on-device way of testing whether your app is accessible to all users. All right. Have you ever tried to debug issues in your app that were maybe only impacting users who have lower memory devices or happening in low memory conditions? I know that I, as an Android developer, often have more higher end device that has a lot of memory. I don't run into some of the problems that people with real devices out in the world do. So one way that you can sort of simulate, give yourself some empathy for folks with lower end devices, is to turn on the don't keep activities option. It's going to destroy the activity, every activity, as you leave it, as if the OS had killed it to reclaim that memory. So it can simulate the unpredictable lifecycle behaviors. So anywhere that you're dealing with save instant state, you're going to be able to find bugs with this option turned on. So if you want to be able to more frequently or predictably run through these cases, turn on don't keep activities, and things will start getting killed off, and you'll actually be able to really test this behavior. Since we're in killing things off mindset, we can look at the background process limit option as well. Similar, the options here are a little bit arbitrary. Standard, what's standard? It's actually 20 processes, turns out. None, or 1 through 4. The reason that you'd want to do this is really similar to why you would want to not keep activities. You want to just run through the OS the life cycles of your app, and the operating system can kill off background processes when it chooses to. So, is your app resilient to that? A way to find out is run no background processes and see what happens. Now, there is obviously some behavior in your app that may depend on background process. If you're trying to fetch data and it doesn't happen because there's no background process, it's not necessarily a bug in your app, but it's, does your UI respond to that in a way that makes sense? Is your zero state good? Is your error conditions, do they make sense? So you can test that. All right, and last but not least, don't be a dope like me and take hundreds of screenshots without turning on the system UI demo mode. All right, this is going to take all of your different icons at the top and your times and turn them into this very consistent, same time, same icons in every screenshot. The only reason I saved this option for last is so you weren't looking at all of my screenshots throughout this whole, and my videos throughout this whole process, pointing this out, because about halfway through I turned it on. And so, yeah, I actually took all of these examples from the rest of the talk, so I felt pretty crappy about that. So here we go. And if you noticed, my sincerest apologies for having to look at my distracting icons. Cool. So hopefully you've learned a few things. And maybe now you'll have some tools that you need to debug and to develop better applications for everybody else with no external tools necessary. So thanks. Are there any questions? One over here.
The overdraw tool, can
Yeah.
you just quickly go over that one again real quick?
Sure. I learned something amazing about Keynote and MacBooks with Touch Bar. I can scroll through all my slides on the Touch Bar and go directly to that one, like some kind of presentation genius. Yeah. If you learned anything today, you learned this. So what is happening here is that different layers are being drawn over the background of a view is being drawn over the same spot multiple times. So in the pink and red areas, if you were to look at this settings screen, the area around this text is all white behind it. But somehow it's drawn over 3 or 4 times, white background, so there's probably a view group holding these things here, and it has a background. And the icons have a white background, but they're drawn on a thing that has a white background. And so you want to set the backgrounds of these elements to be transparent so that they're not drawn, or remove the background so that you don't have to continuously draw that same thing over and over. That's what it is, overdraw. It's just drawing over the same place repeatedly. Cool. Any other questions? All right. Thanks, peeps.